So hello guys, so here's the next question for the problem of the day in Leetcode, that is maximum count of positive integer and negative integer. Okay, so basically this question is straightforward. Basically what we have to do, we have given an array that is sorted. Okay, so we have to basically just return that the basically count of this negative integer and positive integer, basically maximum of those two. Okay, so if negative integer count is greater, then basically we have to return that, and if positive integer count is greater, then we have to return that. Okay, so we have to just like in this case, in this array, these three are negative integer, this three, and these two are positive integers. So obviously this negative integer count is greater, so that's why output is 3. We don't have to count 0 because that here written that 0 is neither positive nor negative. Okay, so you got the question. So you would have got the brute force also. Okay, like what we can do in brute force, we can simply iterate it through, like if we take pointer here I, then we can simply iterate through here, and we can take two counters, that is that will count for positive and negative. Whenever we encounter negative that is smaller than 0, we will simply increment the count of negative integer, and whenever we get the count of positive integer, that is 1 or 2, like, then we will simply increment the count of positive integer, that is simply greater than 0, and whenever we get 0, we don't do anything, we will simply iterate. Okay, so you got the thing. That is basically brute force. Simply you will get then we can simply at last return the maximum of those two counters. Okay, so you can see basically this is the brute force, but it will simply take big of n time. Okay, the time complexity will be big of n. Okay, so if you see that big of n is basically slightly greater. Okay, for this type of question we can do basically in more optimized way, that is big of log n. Okay, if we use here, that is binary search. Okay, if we use binary search here, that is okay, binary search, then we can simply do much more greater. Okay, so let's just do how can we use binary search. So let's just take, I've taken here this array. Okay, so this array, and for binary search there are two things that is you have to learn. That is one thing is lower bound. Okay, lower bound. Okay, and next is that is upper bound. Okay, so simply if you see that upper, let me write upper bound. Okay, so first we will see what is upper bound and lower bound. So lower bound is basically the lowest number. Okay, the lowest number that for this, let's just take for this array. Okay, for this question, so lower bound is the basically let's just first understand one thing more, that is if we see 0, okay, we don't have to count 0. Okay, so 0 will always be in the middle, you know that, because this array is sorted, so 0 will always be in the middle. Okay, negative at left of the 0 and positive at right of the 0. So if we get 0, then we can simply say the left of the, basically if we get first 0, then we can simply say the left of first 0 is all negative, and if we get second 0, then we can say right of all 0 is, basically second 0 is all positive. Okay, so that's the basically lower bound and upper bound case. Lower bound basically states that in this question, lower bound is that the lowest, basically the index on which 0 is there or greater than 0 is there. Okay, because if we get this -1, let's just say lower bound is -1. Okay, so if we see the basically indexes of these, that is 0, 1, 2. Okay, so the index would be simply 2 here. So if we return lower bound, that is so index total would be 2. So but the all number are 3. Okay, there are total number 3 negative integer. So if we get lower bound here, that is on 0, then we can simply return this index of 0, that is that would be simply 3. Okay, we can say that the index of the this is 0 is the total number of negative integer. Okay, because all the left basically numbers are integers, basic negative integers to this 0. Okay, and whenever we get this, so this 0 can be considered as lower bound. Okay, we can say this 0 is lower bound, okay, because it is greater than 0. Basically it is lower bound should be greater than or equals to 0, okay. It should not be basically less than 0, because if it is less than 0, that is if lower bound was here, then we can simply not return the index, okay. We have to add or subtract this time, okay. So basically avoid this complication, we can simply say lower bound would be greater than or equals to 0, just greater than equals to 0, that is here, not this, okay. So what is upper bound? Upper bound would simply be just greater than 0, not 0, because how basically we are saying not 0, basically we are saying because if we get this as upper bound, okay, this one as, we can simply subtract the total size, that is 7, minus this index size, that in basically index number, that is 5. 7 minus 5, that is 2. So the total number of integer that is our positive will be simply 2, okay. So you got the thing. So the upper bound would be simply here, that is just greater than 0, not equals to 0 or less than 0, okay, just greater than 0, okay. So upper bound will always be equals to greater than 0. So you got the thing, that is what is upper bound. So the upper bound would be simply 1, okay. So lower bound is this and upper bound is this, then we simply so simply we can simply return the maximum of these two, okay. That is lower bound will simply be the index of this element, and upper bound will simply be total size minus this index, okay. So simply we can at last return the maximum of these two. How we will find the lower bound, upper bound? We can simply use the binary search, okay. In C++ there is a basically inbuilt function also, lower bound upper bound, okay, but we will use this, okay. That is binary search. How we'll do? We will simply take two basically values, that is low and high, and whenever we will calculate basically also mid, that is mid would be here first, okay. We will calculate also mid, then we will simply every time if the mid is basically for lower bound, if mid is smaller than basically greater than or equals to 0, we will basically put that index, store that index, okay. Small basically greater than equals to 0 okay, sorry about that interruption. And then we will move this high to mid minus 1, and whenever our mid is basically in lower bound, whenever our mid is smaller than basically 0, then we will simply move lower bound, basically low, okay. So you got the thing, how we are going to work in lower bound. Let's just move to upper bound. For upper bound, always we have to get the index for, when the mid is greater than exactly 0. So if the mid is greater than 0, that is here it is equals to 0, then it will simply move this lower to here, okay. And whenever this low will come here, and we will simply store the value in index, that is basically we will see, okay. So we will get this answer. So you got the thing, how this approach will work. Let's see just in Leetcode, okay. Okay, so here's the Leetcode. You can see I have written the code. So here's we have calculated the lower bound, and here's we have calculated the upper bound, okay. So you can see lower bound, low, index and high we have taken, okay, and then low is less than high, then mid will be simply low plus high by 2, and whenever the low nums mid is smaller than 0, we will simply move the low, and when it is greater than equal to 0, we will simply update the value of index and then we return. Same for upper bound, but this time only if the nums mid is smaller than or equals to 0, okay. Whenever the greater than 0, then we will simply update the value, okay. We don't want 0. Then we have to basically simply push positive integer nums dot size minus upper bound, and negative will be lower bound, will be equals to lower bound, okay. We will simply return maximum of this. You can submit it. So yeah, you can submit. So you can also see time complexity, yeah, big of logN, okay. So that's the code.